So we'll move right
Thank you.
over to Nicolas Pocard, who's the Vice President of Marketing and Strategic Partnerships at Ballard Power Systems. He brings more than 20 years of experience in business development and marketing at the international level. He joined the fuel cell industry in 2004 and Ballard in 2012. He's the Vice Chair of the Board of the Canadian Hydrogen and Fuel Cell Association, board member of the California Hydrogen Business Council, and the Canadian Urban Transit Research and Innovation Consortium. Thank you, Nicolas.
Thank you very much. I'm very happy to be with you today. And so I think I'm going to try to, there's a couple of things that have been already mentioned by Sabina. And so I just want to give you here the perspective from the technology point of view. So how hydrogen on fuel cell can really help to decarbonize the marine sector, but not only on the vessel, but looking also at the application on the port. Next slide. Anyway, we talked about that earlier today, and I think this, it's very interesting. Just want to put a perspective. We have been at Ballard. We are technology developer and manufacturers. We have been involved in developing and advancing fuel cell technologies here in Vancouver for the past 40 years now. And what is very interesting is 2 years ago, nobody in the maritime sector, almost no one, was talking to us about hydrogen on fuel cell. And in the past, I would say 18 to 24 months, maybe a bit more, we have really seen a really strong growth in the demand and projects where different operators, either on the vessel side or on the port side, are coming to us and say, we need help, we need solution, we need to decarbonize, we need to find a way to, especially on a heavy duty mobility ship or trucks, we need batteries not going to work, we need also solution. And we strongly believe that hydrogen is one of the paths to enable that decarbonization. So really, really, really strong interest. And if you go to the next slide, that has been done by operators, and I will come to some of the projects we are doing where we are building now ferries and barges using fuel cell, and those vessels are going to start doing operation next year and in the coming years. So I think it's really, really interesting, and it's not only Ballard. I think everyone in the hydrogen ecosystem have seen this growing demand and projects actually happening today. Next slide. So why actually, if you look at the first, starting to look at the as a vessel side, so why hydrogen makes sense on a vessel? So I think the range is one of the issues. I think hydrogen, I was highlighted earlier, might have not the best energy density when it comes as a volume, but a very high energy density per weight. And using liquid, you can start to store really a lot of hydrogen on board of a ship. So enable, when's the limitation? If you're talking here strictly about zero emission vessel, batteries have limitations. It's okay on a small ferry, on a small routes, but whenever you start to have longer routes and longer duty cycle where your ferry or your barge or your vessel has to operate longer hours and have less time to recharge, to be plugged in at the port for hours, then hydrogen provides that flexibility of use. And the fast refueling is one of the key elements of it compared to batteries, and that's why a lot of operators are looking at hydrogen and fuel cell for that. And I think what is important also is a modularity. I think a fuel cell system, like an engine, like a diesel engine, it can be made of sub-module. We can put in parallel, so we can start by doing, maybe just the hotel load to test. So we don't have to provide a fuel cell system to provide the entire energy for the vessel. It can start with doing hotel load on whenever the vessel is at the port. And then we can increase the the fuel cell power system by adding more building blocks in order to go maybe starting for a couple of 100 kilowatts to multiple megawatts at the end. And the flexibility of the design of a fuel cell system allow you to to really dispatch the fuel cell power system across the ship to better utilize the space. And so there's a lot of modularity and scalability in the fuel cell system, which makes the retrofit very possible, as well as evolution over time of the power system of the vessel. And fuel cell, fundamental of a fuel cell, it's a solid state technology, very few moving parts. So maintenance It's very low. You don't have oil. You don't operate at very high temperature. We're not burning anything. It's an electrochemical reaction. So very important in terms of reliability, very important in terms of maintenance, very important in terms of efficiency. And I think we need to look at really the efficiency, not just, the classic, we look at the efficiency on a ship, as well as when you look at the overall efficiency, you need to look at the energy efficiency from availability of energy, and also whatever is actually used compared to what could be used. I think that's a very important consideration to have. So anyway, if you go to the next slide, just want to show here some, at Ballard, as we say, we have been doing that for the past 40 years. We're really looking at heavy duty mobility, and that's really what we're focusing on today, to develop fuel cell engines for application like bus, trucks, rail, and marine, where we believe that hydrogen delivers the best value proposition. Next slide. And so what is very exciting today is, as I mentioned earlier, is just within the past couple of years, we are now actually building marine vessels which are integrating fuel cell and hydrogen as a fuel. And so it's happening today, and it's not just products for tomorrow. So some of the operators and vessel owners have made the jump, and I say, yes, we're going to start building ferries, we're going to start building barges and push boats, because we believe that hydrogen is one of the solutions that we need to deploy in operation. Next slide. So we do have today a number of ships which are in development, mainly in Europe. I think at the moment we start to see that really happening a bit faster in Europe than we see in North America. So I think the most exciting project is the one we have with Norled. Norled is one of the leading ferry, I think the largest ferry operators in Norway. They operate a number of ferries along the coast of Norway, and we are doing two projects with them. Both are a ferry project, but one will be using liquid hydrogen, and that will be the first liquid hydrogen ferry ever built. And the second one is a smaller ferry which is going to do compressed hydrogen. So we'll be able to have both, and both ferries are not just R&D projects. They are going to be deployed. They're going to be operated by Norled in a passenger revenue route. So that's very important. There's a third ferry that we are working in Scotland with Caledonian, and that ferry also is being integrated at the moment, is being built, and is going to use gaseous compressed hydrogen. And so I think all those projects, we expect those ferries, building is happening now, integration is happening, and those ferries should start testing on operation by 2022 and some 2023. But it also goes beyond ferries. We have a lot of interest, and we are building a number of barges, river barges, to operate on the Rhine and Rhone River in Germany and in France. And because that's also an area where decarbonization is very important, and the ports also of Amsterdam is looking at of Rotterdam is looking at a number of barges which are going to be deployed. So very exciting time. We are building a vessel now, and so we're going to get some real data and look at the challenges, because there are challenges. Is really implementing a brand new fuel and a brand new engine technology on board of vessel. So it's very important to get those initial projects rolling. Next slide. But so that's basically some integration. How the an example of how the fuel cell is going to be integrated into a marine vessel. Next one. So, and this is a product. So what it looks like. This is a fuel cell system, as I mentioned. It's kind of a cabinet. Basically,
you're muted suddenly, Nicolas.
Sorry. Yeah, so this is a 200 kilowatt building block, and as I mentioned earlier, you can have 10 of those, for example, to do a 2 megawatt power system. They can be distributed in the engine room or in the power compartments. So really specifically designed to marine environment with the NVGL to get the type approval for those marine vessels. So really moving forward to developing dedicated fuel cell propulsion solution or power solution to power electric propulsion of marine vessels. Next slide. So, and I just want to finish with a couple of slides very quickly over, beyond the vessel. So, and I think it was very much highlighted by both BC Ferry and the Port of Vancouver that there's a numbers of vehicles which are operating around the marine vessel on trucks. And you have some shore power, which is needed for some of the marine vessel when they are at the port. Barges operating on rivers. You have drayage trucks in out of the port, which are creating a lot of pollution in those corridors, linking the port to the distribution warehouses, rail terminal, and of course all the material handling equipment. So all those equipment are heavy duty. They need a lot of energy to operate very long hours, and this is really where we believe that hydrogen and fuel cell can play a critical role. Next slide. So, and I think the value proposition for the operators here is really, first of all, is zero emission. The quick refueling is very key. And this is, you want to maximize your assets. If you have assets operating on a port, sometimes you have to operate 24 hours a day. So having the ability to refuel your vehicle in 10 minutes is very important. And there's no payload compromise. I think it's important if you have a truck, if a drayage truck operating, you don't want to have half of the truck or 40%, 30% of the truck load being used to carry batteries. I think the very high power density per weight of hydrogen is very critical for those applications, so you don't compromise on your payload and you can carry as many goods as possible. Next slide. So now we start to see more and more fuel cell vehicle being deployed at ports. We're very excited with the products at the Port of Vancouver and the yard truck they're going to be operating at by BC Ferries. And this one is a drayage truck, which has been in operation now for 2 years at the Port of LA, fuel cell Class A drayage truck, which have accumulated a lot of mileage and have really shown very, really high performance to deliver goods in and out of the port. Next slide. So I just want to have a reflection just to finish my presentation about, what do we need to do in BC? I think it was highlighted earlier, we had really a unique position in BC. First of all, we have access to all the renewable energy from hydro, which will enable us to really generate a green hydrogen. And we have this unique ecosystems of companies, of technology, of know-how, which is unique in the world. I think there's no other places, but in a Lower Mainland, in British Columbia, where we have all that ecosystem, representing the entire value chain around hydrogen production, distribution, fuel cell components and systems. I think it's quite a unique opportunity to create jobs here using the technology which is developed and made in a province. But I think for me, there's two imperative that, if you want to be successful and contribute to the decarbonization of a port and a marine sector, I think we need to really, foster the production at scale of low carbon hydrogen. I think without green hydrogen, affordable green hydrogen, produced locally, we are not going to go anywhere. This is the first building stock that we need to really, generate that production of affordable green hydrogen. And the second, I think, technology is working, fuel cell is working. There's nothing to wait and demonstrate. So now we can go, we hope that we can put more vehicle. When I use demonstration, it's not from the sense of technology demonstration. Fuel cell works. There are, thousands of fuel cell heavy duty bus and trucks in operation worldwide. What we need to do in demonstration is a sense of, for the user, which are new to the technology, to understand how you integrate into the operation. But it's not, so we can deploy fleets of vehicle on trucks, of yard trucks, start to look at, evaluating shore power, and then looking at how ferries and barges can be starting in operation in a region. So I think the technology is ready, the ecosystem is ready, and I think they're all linked together. If we have the production at scale of low carbon hydrogen, we are going to need offtake to make sure that it's a viable investment to produce hydrogen. And I believe that the ports and the maritime sector can really be a very critical off-taker of this green hydrogen to make the economics work and create new jobs in a province. Thank you very much.